Washington State University. Go Cougs!
Hello everyone. In this video, I'm going to cover the first lesson of the Working with Activity and Health Data module. This lesson is going to begin our discussion of data cleaning. So let's take a look at data cleaning and why it is so important and so time-consuming for data scientists. Here we have a chart that represents survey data that was collected from data analysts to see what are the most time-consuming parts of their job. So this big chunk here, 60%, that is in fact cleaning and organizing data. So it takes a lot of time just to prepare data for other parts of the data analyzing or data mining data pipeline. For example, building training sets, mining data for patterns, and refining algorithms are all steps that occur after cleaning and organizing data. So cleaning data and data preparation includes, but is not limited to, tasks such as the following. Loading data into an appropriate data structure. This could be a Pandas series or a Pandas data frame, for example. Merging multiple data sets. So you can imagine if you have several CSV files spanning several different folders that you need to read in and merge into, say, a single Pandas data frame. And then we have cleaning the data, which I have some examples here of what needs to be done to clean data. Reshaping, transforming, and changing data type. We've actually seen a few examples of how to do this already in Pandas. Replacing values, especially if there are duplicates and perhaps our domain does not allow for duplicates. Performing data binning and discretization. This could be useful for plotting histograms and preparing for machine learning algorithms. Handling missing values. We'll come back to this topic here shortly. Detecting outliers and handling them accordingly, and standardizing and scaling data. This piece is especially important if you plan to use this data for a machine learning algorithm that requires data to be standardized before using it. So let's talk a little bit more about missing values. Values can be missing in a data set for several reasons. It could be a participant started a study but was unable to finish it. It could be a sensor failed, perhaps the batteries died and it wasn't detected for some time, or perhaps something happened with the database and the integrity of some data has been compromised. In these cases, missing data is typically coded in several fashions. For example, it could just be blank, so just completely missing. It could be -1 if it's a numeric field, where negatives aren't allowed. It could be an empty string in a string field, or maybe a special string such as a question mark. In the SciPy ecosystem, there's a special value that's used to represent missing data, and that's NaN, which stands for not a number. So there's special support in Pandas to work with NaNs, and we're going to take a look at how we can use those. So there's the Pandas function isNull, which returns a Boolean array detecting NaN values element-wise, and dropNA, which will remove NaN values from a series or from a data frame. So here I have some code where I've already imported NumPy and Pandas. I've made an ND array of 10 values, and I've created a series from those 10 values. So just for good practice, let's print out that series and see what it looks like. Okay, here is our index and here is our value. Now let's go ahead and replace some of these values with NaNs to denote missing values. Let's say Sarah sub 1 gets np.nan and maybe also Sarah sub 5. So we'll have 2 missing values. And then we'll print this out and we'll see those values have been replaced with NaNs. So now let's get that Boolean array. We'll call it nans, which is going to represent whether or not each item, element-wise, is a null value. We'll print it out, and we see all falses except for in positions 1 and 5, which are actually NaNs. So now, one more example. We can go ahead and remove the missing values from this series using the drop NA function. So let's go ahead and call drop NA for SARE. Now this is going to return a new series without the missing values. But if I specify the flag or the keyword in place to true, then it will make this modification in place in memory. So now if I print out SARE again, I see that 1 and 5 are missing because they have been dropped from our original Pandas series here. So from here on out, instead of looking at individual cases of these different tasks for how to clean and prepare data, we're going to immediately start working with some real activity health data and see how we can clean it to prepare it for later parts of our data processing pipeline. So the data that we're going to work with is in a data set called pd_hoa_activities.csv. If you click on this link here, you can go ahead and download it. So this stands for Parkinson's disease, healthy older adults, activities. And let's take a look at what it looks like. So here's what the data looks like. Zoom in a little bit. So here, our first row is our header row. So we have PID, participant ID. This is going to be an integer representing an ID. It has task, which is going to be an integer representing a task. Duration, which is how long it took this particular participant in seconds to perform this task. Age, which is how old is this particular participant. For example, this participant 0 is 72 years old. And class. And class can be one of two values, healthy older adults or Parkinson's disease. And we're going to see there are a few different ways healthy older adults and Parkinson's disease were coded in this data set. And we're going to have to clean that up. Those activity or task IDs, 1 through 8, are listed here with what the string label or the string representation of that task is. So for example, 1 is water plants. So something we might want to do to make this data more readable is to replace the 1 with water plants. If you want to read more about how this data was collected and what it represents, please see this paper here, which was published in 2015. So now let's take a look at actually loading the data up in Pandas and being able to do some initial exploration of the data. So here I've already included our imports, so we are ready to immediately start writing code. I've included the file name here, so I have this file downloaded on my machine, pdhoaactivities.csv, in a folder called files that is in my current working directory. I don't need this R anymore here. If you're on a Windows machine, you will need that R and you will need to flip this slash to be a backslash the other direction. But I'm on a Mac, so I can remove that R and work with forward slashes. So the first thing that I'm going to do is use read CSV in order to load this data into a data frame. So let's have df is assigned pd.read.csv, and we'll read in fname, and we'll set header to be that 0th row there. And let's print out the shape, and let's print out the number of participants in this data set. And note, this is not going to be the number of rows or the length of the index in the file, because we have 9 tasks per participant. So we're going to have to integer divide by 9 in order to find out exactly how many participants are in this data set. So if I run it, I see we have a 675 by 5 data frame, and 675 integer divide 9 is 75 participants. Now, the last things we're going to do here is do a little bit of exploration of the data to set the stage for our next lesson where we're going to clean this data. So let's go ahead and take a look at the first 5 rows of our data set. Okay, so we already saw this when we looked at the data as a CSV file. And let's take a look at the last 5 rows. Okay, so here we see participant 74, which confirms that there are 75 participants. Their durations here look a little bit faster, except for this last one, the day out task, took quite a long time. Slightly older participant. This participant does in fact have Parkinson's disease. And then there's a certain range of values that I want to look at so we can see some missing values. So I'm going to print out rows 660 through 670, 7 through 10, and 25 through 28, just so we can see that there's some missing values here denoted with string question marks, and we have quite a few different ways of encoding. Here we have HOA capitalized, HOA lowercase, here we have PD as an acronym, here we have Parkinson's disease spelled out. So we're going to do some cleaning of our class column in our data frame before we're ready to work with this. And the last thing let's take a look at is how we can figure out how many missing values we have in our duration column, which is where we have these question marks here. So I'm going to go ahead and index into the data frame at duration in order to get a series of all the duration values. And I'm going to use value counts in order to count the number of question marks. And if I run this, I see there are 10. So there are 10 missing values in this duration column that we're going to need to think about how we're going to handle. And we will do that in the next lesson.